Hey everyone, today we're diving into the world of magnets with magnetic flux and flux density. Magnetic flux is all about the total magnetic field flowing through a surface. Think of it as counting those invisible magnetic lines crossing through, measured in Webers. Then there's flux density, which tells us how strong that magnetic field is in a specific spot, measured in Tesla. It's like the intensity of the magnetic action. Stick around as we unpack these concepts and see how they power the magnetic wonders around us. This is a magnet. This is the magnetic field around it. We know these magnetic field consists of magnetic lines of force which are passing from north pole to south pole of the magnet. Now take a small cardboard and place in magnetic field. Observe some magnetic lines passing through surface of cardboard. Let's say 3 magnetic lines are passing. These 3 magnetic lines passing through the surface gives magnetic flux. Observe this line is not passing through surface, so this line is not counted. Similarly, other lines that are not passing are not counted. Definition of magnetic flux. The number of magnetic lines of force passing perpendicular to the surface area of a plane in a magnetic field is known as magnetic flux. It is denoted by phi. The unit of magnetic flux is the Weber. Magnetic flux is a scalar quantity. Now, if the plane is bent or tilt makes an angle of theta with the magnetic field, in this case, how to calculate magnetic flux? Phi is equal to B bar dot A bar is equal to B a cosine theta. How to get this means in vector chapter, we already studied resolution of a vector. I will provide a link in the description. Okay, here theta is the angle between B bar and A bar when the magnetic flux is maximum, and minimum means if we place a plane perpendicular to the magnetic field as shown in figure, then area vector and magnetic field are parallel, then theta is 0. If we substitute this value in equation, we get phi is equal to B bar dot A bar is equal to B a cosine theta is equal to B a cosine 0 is equal to B a, because cosine 0 value is 1, therefore magnetic flux is maximum. If we place a plane horizontal to the magnetic field as shown in figure, then area vector and magnetic are perpendicular, then theta is 90 degree. If we substitute this value in equation, we get phi is equal to B bar dot A bar is equal to B a cosine theta. If theta is 90 degrees, then we get B a cosine 90. Here cosine 90 is 0. Therefore phi is equal to 0. Magnetic flux is minimum. Magnetic flux depends on magnetic field strength and how surface of the object is placed inside magnetic field. Now let's understand what is magnetic flux density. In magnetic flux, we considered whole surface of cardboard, but in magnetic flux density, we consider only unit area of the surface. Place this cardboard in magnetic field such that angle between cardboard and magnetic lines is 90 degrees. Observed magnetic lines are passing through cardboard surface. These are called magnetic flux. Again, observe some magnetic flux passing through this unit area. This magnetic flux passing through unit area is magnetic flux density. Observe in figure the number of magnetic lines of force passing through the cardboard are 4, so magnetic flux is 4. But the number of lines of force passing through unit area are 2, so magnetic flux density is 2. We know that phi is equal to B bar dot A bar is equal to B a cosine theta. Here area vector and magnetic field are parallel to each other. Therefore theta is equal to 0. Substitute this value in equation, we get phi is equal to BA. B is equal to phi by A. Here B is called magnetic flux density. Definition of magnetic flux density. The number of magnetic flux passed through unit area on a surface is called magnetic flux density. Magnetic flux density B is equal to phi by A. It is a vector quantity. Unit is Weber per meter square or Tesla. Dimensional formula for magnetic flux is ml square T power minus 2 A power minus 1. How to get this? Just recall the chapter units and dimensions, or I will provide a link in description. Thanks for watching Pathfinder 6. Like, comment, share and subscribe to my channel.